So now in this video, what I'm going to show you is how a potentiometer works. Exactly how a potentiometer works. So, like, if you would open up a potentiometer, it would sort of be like I'm going to show you an example. Lost my pen. Okay, and so basically, also I want to kind of explain how a potentiometer really works, how it does its job. Basically, in a potentiometer, there is only one resistor. One resistor, it's not two. Okay, and this resistor is 10k ohms. Okay, or it can be any type of ohm, 5 ohms, but most of the times for the ones that we get on those kits, they're all 10k ohms. Okay, and these, and basically they have a resistor sort of like this right here, like this normal piece of wire. Okay, so it's not like covered into some type of like material that you usually see in normal resistors. It's We're able to touch the material that actually causes the resistance. Something to actually, you're able to see the actual resistance material. Okay, and so let's say this piece of wire is 10k ohm. This is basically a resistor here. Okay, so let's pretend that it's 10k ohm. It's not 10k ohm, but let's pretend that it is. Okay, and so this is exactly how it is inside of a potentiometer. You would hook the positive side, like positive voltage here, and negative voltage here. Okay, so right when you hook positive and negative voltage, power will begin to start flowing through this resistor. Okay, but let's say we take a wire. Let me get a wire. Actually, wait a minute. So let's pretend I'm hooking my positive here, my negatives right here, and power begins to start flowing through here. And this is 10k ohm. This is 10 ohms right here. It has to travel through 10 ohms. So if I would read this ohms, this would be 10 ohms, 10k ohms. But if I begin to start moving the negative over here, like right here, this will be 5 ohms, 5k ohms, because I halved it up. It's basically like cutting the wire in half, and when you cut the wire in half, or the resistor in half, then you get half of the ohms. So basically here is like 5 ohms, 5k ohms, and then we're going to half it up again, and we get 2.5k ohms, okay, here. And so basically, as we continue to move here, around here with the negative, with this other pin, the ohms begins to decrease right here and increase. So we can change our resistance based on moving this wire around this resistor. And so basically, this is how it is. We have a adjustable knob here. I use some type of screw or bolt. And we have a wire here that is actually the middle pin. This wire is supposed to be connected to the middle pin. So it's that third pin that's in the middle, in between those, it's the pin that's in the middle of those 3 pins, in the middle of those other 2 pins. And so that's the middle pin. This is the pin that you would be reading analog, you would be hooking up to the analog pins. Let's say we hook here, and it's touching it, and right now there's not much resistance from the positive to the 5 volts and to the analog pin. Okay, so the analog pin saying, hey, we have a lot of voltage here, so it's going to be 123. That's the maximum value that the analog Arduino can give us with the analog. So right now it's giving us 1023, and as we begin to start toning, that number begins to decrease because the ohms are beginning to go higher and higher and higher, and they're beginning to raise. The ohms are beginning to raise, and now it's like half. So this is 5k ohm. So now the voltage begins to drop because it has to walk through this resistance. As we continue, it drops and drops and drops and drops and drops some more, and eventually it makes it to negative, which is 0. Negative is 0 voltage, and so it reads no voltage from the negative. Okay? So the reason is why we had to connect, you may just say, why not just connect positive and not worry about the negative? But the issue is with that, is that if you have that issue, then the analog pin will be always reading 100, 1023, 123, 1023, because there's nowhere for the power to go. Okay, the power has to be flowing, has to be going somewhere so that we can read the value voltage. Let me explain. Basically, let's say we were, sorry, let's say we're right here, okay, and the power comes over here and flows into this pin. It realized, hey, the power is willing to come to the analog pin, and without doing the rest of this walk going through this other part. This is the resistor. It's willing just to go to the analog pin because that's quicker, right? Well, the analog pin isn't taking all the power. It's only taking a very small amount of voltage to just get the reading done. Okay? And so the rest of the power is like, oh well, there's nowhere else to go, so why not walk through the rest of this resistor to get to ground? Okay? So if you disconnected ground, the power would have nowhere else to go but that pin. Okay? So you will always have power, all this power trying to get to the pin, and the pin will read always 5 volts. Okay? Or whatever voltage you're giving this potentiometer. So that's basically how a potentiometer works here. So it's somewhat easy after you realize how it works. But yeah, that's how it was. Is how a potentiometer works. Hopefully, you got that. So yeah.